Welcome to Lesson 5, where we go from using someone else's copilot to designing our own AI agent. We'll build, conceptually, an endpoint triage agent. It ingests an alert, gathers telemetry through tightly scoped read-only tools, reasons about the likely cause, and produces a verified recommendation. The crucial part, it never takes a consequential action itself. It stops at the recommendation and hands off to a human. Let's define an agent precisely. A single prompt gives you one answer. An agent is a language model running inside a control loop. It plans, calls a tool, observes the result, and decides its next step, repeating until it reaches its goal. That loop is exactly what lets an agent investigate rather than just respond. For endpoint triage, the goal is fixed and modest: given an alert, find the likely cause, recommend a fix, and then stop. An agent is only as safe as the tools you hand it. A triage agent investigates, so it must never change a device. That means every tool is read-only and scoped to exactly what triage needs: query telemetry, get device state, get compliance status. Notice what's missing: no isolate, no wipe, no push config. The moment you add a write-capable tool just to save a step, you've removed the human gate. Don't. Investigation and consequential action live on separate paths. The system prompt is where you write the contract. It fixes the agent's role, its allowed tools, and the shape of its output. Treat it as a contract, not a suggestion. It states the agent is a triage assistant, that it must never change a device, that it uses only the provided read-only tools, that it cites evidence, and that it responds only as JSON with a required human approval flag set to true. And if evidence is insufficient, it must say so rather than guess. Left unconstrained, a model will happily fill gaps with plausible fiction. You prevent that by grounding every conclusion in tool output. Two measures do most of the work. First, require cited evidence for each claim, so an unsupported conclusion is visibly missing its evidence. Second, require an explicit confidence level plus a flag for insufficient data, so uncertain cases route to a human instead of hiding behind false confidence. Grounding is how you keep the agent honest. Why insist on structured output? Because free text is hard to check, and structured JSON is not. A schema with likely cause, evidence, confidence, recommended action, and requires human approval makes the agent's reasoning inspectable, machine checkable, and auditable. It forces the agent to cite evidence and state confidence rather than ramble. The principle in 5 words: the agent proposes, a human disposes. Let's gather the guardrails for agents. 1. A tool allow list, so only read-only tools even exist in the agent's world. 2. An output schema that's verifiable and carries its evidence. 3. Confidence reporting, so uncertainty is surfaced rather than hidden. 4. Audit logging, so every tool call and every recommendation is recorded. With these 4 in place, the agent never crosses into the act stage. Crossing that line is the subject of Lesson 6. So where does the agent hand off? It produces a recommendation, with evidence and a confidence level, and then it stops. A human reviews that evidence and confidence. Only an approved human triggers the separate action path. Keeping triage and remediation deliberately separate is what makes the whole design safe, and it's exactly the boundary we'll engineer carefully in the next lesson. Let's recap. An agent is a language model in a tool calling control loop. A triage agent's tools are read-only and least privilege. Its system prompt, its JSON output schema, and telemetry grounding are what keep it honest, and it always stops at a recommendation. Your task: design a triage agent for one real alert type in your environment. List its read-only tools and scopes, write its system prompt, and define its output JSON schema. Then write 3 lines on how a human reviews its recommendation before any action is taken. Next lesson, automating remediation safely.